In this episode, we are going to pause the introduction of new technology terms and instead strengthen your ability to recall and apply what you have already learned about defensive stacks, SIM correlation, EDR, and DR, automation, and AI. It is one thing to nod along while hearing how logs flow into alerts and how endpoint and network visibility complement each other. It is another thing entirely to reconstruct that flow from memory when presented with a short scenario. Spaced retrieval is the process of deliberately recalling concepts after time has passed, and it is especially useful for security learners because defensive thinking depends on structure, not memorized definitions. By practicing rapid recall through short triage decision prompts, you train yourself to think in layers, connect signals, and choose the most defensible action under pressure. That skill translates directly to exam questions and real-world analysis. Before we continue, a quick note. This audio course is a companion to our course companion books. The first book is about the exam and provides detailed information on how to pass it best. The second book is a Kindle-only ebook that contains 1,000 flashcards that can be used on your mobile device or Kindle. Check them both out at cyber.author.me in the Bare Metal Study Guide series. Let's begin with a simple retrieval prompt about the defensive technologies stack. Imagine you are told that an organization receives thousands of raw log events per minute from identity systems, endpoints, and network devices, but analysts complain that they cannot tell which events matter. Without looking at notes, describe mentally the three major roles in a defensive stack: collection, normalization and storage, and detection with alerting. Ask yourself which role seems weakest in this scenario. The problem is likely not collection because data is arriving. The weakness may be in normalization, correlation, or detection logic that fails to transform raw data into prioritized alerts. This recall exercise forces you to reconstruct the flow from logs to telemetry to alerts. If you can identify the missing link quickly, you are building the mental model needed to reason through exam scenarios where the question hints at structural gaps. Now try a prompt focused on SIM correlation. You are told that analysts receive separate alerts for failed logins, unusual outbound traffic, and administrative account use, but each alert appears unrelated and is investigated independently. Pause and recall what correlation is meant to do. Correlation connects separate events into a higher confidence narrative. In this case, a failed login followed by a successful login, followed by unusual outbound traffic and administrative activity, may form a single story of compromise. The retrieval task is to articulate why correlated alerts are more powerful than isolated ones. They reduce noise, provide context, and support faster triage decisions. If you can explain that sequence without rereading definitions, you are strengthening your ability to apply the concept rather than simply recognize it. Let's move to an EDR-focused recall drill. Imagine that an alert reports a suspicious process running on a server. The alert includes process name, parent process, command line arguments, and file modification details. Without looking back, list mentally what EDR is best at seeing. It captures local device behavior such as process creation, file access, registry changes, and user activity. Then ask yourself what EDR might not show clearly. It may not show broader communication patterns across the network or data flows between multiple systems. This retrieval forces you to articulate both strengths and limitations. Being able to state both sides from memory prevents overconfidence in any single layer of visibility. Now consider an NDR retrieval prompt. You are told that several internal systems are making periodic outbound connections to an unfamiliar external destination. There is no immediate endpoint alert. Pause and reconstruct what NDR is designed to observe. It sees communication patterns, connection frequency, data flow volume, and relationships between systems. Ask yourself what this pattern might suggest, such as possible C2 communication or coordinated behavior across devices. Then recall the limitation. NDR may not reveal the exact process responsible on each device. By articulating both the insight and the gap, you practice layered thinking. This is important because exam questions often require you to choose an answer that recognizes complementary strengths rather than single solution thinking. Next, let's practice combining EDR and NDR in a single recall scenario. Imagine an alert about unusual outbound traffic is paired with endpoint telemetry showing a rare process spawning a command shell. Pause and reconstruct how these layers reinforce each other. The network pattern suggests suspicious communication. The endpoint pattern suggests suspicious execution behavior. Together, they create higher confidence. The retrieval exercise is to explain why this layered correlation reduces uncertainty. When you can describe this integration clearly without notes, you are internalizing defense in-depth reasoning rather than memorizing tool names. Now turn to automation and triage decision practice. Imagine a system automatically isolates any device that triggers a high-risk score. One day, a critical production server is isolated because of a false positive. Pause and recall the concept of dangerous overtrust. Automation is valuable for repetitive, low-risk tasks, but high-impact actions require safeguards and confidence thresholds. Ask yourself what a safer design might include, such as requiring multiple correlated signals or human approval before isolating high-value assets. This retrieval reinforces that automation should accelerate decision-making, not replace it entirely in sensitive contexts. Let's add an AI-focused prompt. You are told that an anomaly detection system flags a user for unusual login timing and device usage. Later, you learn that the user was part of a legitimate overnight maintenance project. Pause and recall the concept of baseline and drift. Anomalies are deviations from typical behavior, but typical behavior can change. The retrieval question is what safeguards should exist to reduce overreaction. The answer might include reviewing context, confirming with system owners, and continuously tuning baselines. Practicing this explanation helps you remember that AI outputs are hypotheses, not verdicts. Now consider a prioritization drill involving severity and confidence. You receive two alerts at the same time. One involves a privileged account on a critical database server with moderate confidence. The other involves a low-privilege account on a test system with high confidence. Without notes, recall how severity and confidence interact. High severity with moderate confidence may still require rapid attention due to potential impact. Low severity with high confidence may be important but less urgent. The retrieval exercise is to justify which alert should be triaged first and why. Being able to articulate that trade-off from memory strengthens exam performance and real decision-making. Let's practice identifying gaps in coverage. Imagine a cloud application experiences suspicious data downloads, but there are no relevant logs available for review. Pause and reconstruct the concept of coverage in blind spots. If logging was not enabled or collected, the defensive stack cannot provide answers. The retrieval question becomes what improvement is needed. The answer is not simply adding more alerts, but ensuring collection and normalization of the right telemetry. This reinforces the idea that detection quality depends on foundational visibility, not just clever rules. Another recall drill involves enrichment. Suppose an alert appears about a suspicious login, but no context is attached. Analysts must manually check whether the account is privileged or whether multi-factor authentication was enabled. Pause and explain from memory how automated enrichment reduces tree-off time. Enrichment adds asset criticality, user role, recent activity history, and related alerts to the case. Practicing this explanation strengthens your understanding that automation is safest and most valuable when applied to information gathering rather than immediate disruptive action. Now try a combined scenario that touches multiple concepts. An alert shows unusual outbound traffic from a workstation. EDR shows that a new process executed shortly before the traffic began. The user account involved has administrative privileges. Pause and articulate from memory the likely tree-off steps. You would correlate endpoint and network signals, assess severity due to administrative privileges, verify whether the behavior matches known patterns, and decide whether containment is appropriate. This retrieval integrates stack flow, correlation, layered visibility, and triage prioritization in a single mental exercise. One more exercise involves tuning and feedback. Imagine that analysts repeatedly close a specific alert type as benign because it matches normal maintenance tasks. Pause and explain how tuning improves scalability. The detection logic may need refinement, such as excluding known maintenance windows or combining additional signals before triggering. This reinforces that a mature defensive process includes continuous improvement rather than static configuration. As you continue spaced retrieval practice, notice how quickly you can reconstruct these connections. At first, You may pause and search for the right phrasing. Over time, your responses become smoother and more structured. That fluency signals that the concepts are embedded, not just stored. Short, frequent recall sessions are more powerful than long passive reviews because they force active reconstruction. Each time you retrieve the relationship between logs, correlation, EDR, and DR, automation, and triage, you strengthen the mental pathways needed to apply them under pressure. By the end of this lesson, the goal is not perfect recall of definitions, but confident reconstruction of relationships. Defensive technologies form a flow from collection to normalization to detection. SIM correlation connects events into stories. EDR and ND provide layered visibility into device behavior and communication patterns. Automation accelerates enrichment and low-risk actions, while AI supports detection but requires verification. The decision rule to remember is this: when given a defensive scenario, pause, identify which layer provides the signal, assess severity and confidence, and decide whether automation should assist or whether human review is essential before action.
Thanks for listening. For more audio courses, daily newsletters, and more, please visit BareMetalCyber.com.